Okay. Are we good to crack on? Let's crack on. Well, welcome everyone to the next session on emerging property risks and building resilience. I should have called it building and infrastructure resilience. I could have called it campus resilience. You know, whether it's a university campus, a residential college campus, whatever. You'll see why in a minute. There's the leading slide. What we're going to talk about today is something that we're seeing more of in the Unimutual claims experience. That's water damage. We're seeing water damage primarily through failed hydraulic services, but also through water ingress through the building envelope. Often, one of the problems that occurs as a result of, either failed hydraulic services or water ingress through the envelope is mould and mould, how to mitigate mould, right? We'll then carry on and we'll talk a little bit about asset resilience under a changing climate and what the natural perils are that we've got to pay attention to, and sometimes how these can compound into a situation that makes the event or the series of events actually quite damaging. Classic example is just what we've seen with tropical cyclone Narelle hitting, already flooded Queensland and flooded Northern Territory and dumping a whole lot more water into that system. That's just an example of a compounding natural hazard event. And lastly, we'll talk about a project we've got afoot, which is relevant to everybody, and that is hail testing and resilience guidance material that we'll be preparing during the course of the year. The hail testing is an initiative, a collaboration between Unimutual, TEFMA, which is the Tertiary Education Facility Managers Association, and the Cyclone Testing Station at JCU. So on to failed hydraulic services. And one of the big issues is ageing buildings and infrastructure. I mean, we're not getting any younger, right? Look at me. Right? I used to be handsome, but I'm not anymore because I'm getting older and I'm breaking down, just like some of these buildings, right? You think about the buildings on your campuses, your college grounds. Some of them are, 40 to 60 years old at least, if not older. And so's the infrastructure that supports them. So the water, the power often, the wiring, all those sort of things, that doesn't often get changed within a building unless there's a major refurb. There's other things like legacy hazards, asbestos, etc. We're getting better and better with dealing with those issues all the time. One of the things we see a lot of is undocumented modifications to buildings. Right? Someone's had a brilliant idea, put something in, not documented it, and then somebody gets a surprise 15, 20 years down the track. Back in the days when we built some of these buildings, they complied with the codes, right? They don't any longer. And as soon as you touch them, you've got to upgrade those buildings to those codes. And we'll talk a little bit about this later. I mean, the National Construction Code is, the building code by which we go, but it focuses on life safety, not necessarily asset resilience. So something to bear in mind. And what we tend to do is we tend to spend a lot of money fixing these old buildings, and that's displacing capital renewal opportunities, right? So more money we spend over here fixing a problem, less money we got over here to build something good and new. The other issue too is that there's always an opportunity in this day and age to upgrade the digital infrastructure. So you're upgrading digital infrastructure into an old building that eventually is going to come down, right? Just have a think about that, let that, rattle around in your mind. Yeah, functionality and utilisation are usually poorer in older spaces. Yeah, okay. Well, that makes sense, doesn't it? Who wants to use an old building when you can use a new one? Flexible spaces, and we're seeing more of these being created on campuses and so forth across the country. They tend to increase asset utilisation, but at a cost with some of the legacy assets that just get neglected, right? Water damage. You look around this building. Well, we've got sprinkler system in here. We've probably got other hydraulic services, in the back walls and around. These things are out of sight, out of mind, right? How often do you think about what's sitting behind the wall, or where your pipes come from and go to? They fail at joints typically, but not always. Sometimes the pipe walls can fail. Braided flexible hoses have a massive failure history. Just think about where you've got braided flexible hoses, either in your own home or in your institution, right? They're under sinks. They connect toilets. They are in water cooling units. The water units, you get a drink, they're in there. They're everywhere. Other hydraulic services with failure potential, the list is there. Wastewater pipes, hot water systems, we see a bit of that. Reverse osmosis systems, you probably don't have these types of things in the colleges, but they do in the universities. And we see every iteration of reverse osmosis systems. Basically, create deionised water, clean water, by forcing water through a membrane, right? So the system's under pressure and they fail at various points. Hose reels and hydrants. God, the number of landing valve seal failures we've seen over the course of the past couple of years has blown my mind. Alloy connectors. If you've got hard water chemistry, alloy connectors in systems tend to corrode, right? And it only takes 5 to 10, maybe 15 years for these connectors to absolutely fail catastrophically. And one of the things, and it's not so much relevant to the colleges, but for the universities, and it is actually relevant to the colleges, not in terms of high value equipment, but say, you've got a great library with some, rare books, some great artwork. Just look for the clash detection, use clash detection. So what do we mean? What's the interplay between your hydraulic services and your high value stuff underneath it, or in a basement, for example, right? Why do they fail? Well, we've listed out the reasons here. General corrosion is one. Water chemistry, and the photo there is a classic water chemistry failure involving the pipe wall. Now, this B-grade copper was flooded across the Australian market during the 80s. And now we're seeing the impact of that in our installations today, particularly where you've got hard water. That's a pipe wall failure. We see catastrophic end-of-life failure, equipment malfunction, the use of inappropriate materials. That material is inappropriate, but they didn't know that at the time, right? So these are all lessons that we learn. And it's important that we communicate some of these lessons. Design and installation issues, lack of appropriate pipe installation support, seen that a few times. One of those events using, and get this, in a lab, agricultural poly pipe and elbow joint connectors wired into the roof cost $800,000, right? That's not happy days. That's wasted money. We also see fluctuations in water pressure for a range of different reasons. Operational failures, human error, ageing infrastructure, insufficient assessments of condition, right? How often do we condition assess the pipe work we don't see? Oh, I reckon never. But there are ways and means of doing that now, and you know, you can stick little cameras down pipes. You can do all sorts of stuff these days. You can use AI tools actually to assess condition and identify potential for failure. But that's you know, that's almost a webinar in itself, that issue. Some of the external factors, ground movement, reactive soils. You know, you've got a clay soil, fills with water, you know, it expands, then it dries out and it contracts, you know, and you get that cycle over a period of years. It can affect your in-ground infrastructure, particularly if you've got old asbestos concrete pipes, right? There's, people don't think about that stuff. Seismic activity is another one, and we're seeing, unfortunately, more and more malicious intent and vandalism. Basically, people turning valves on, right? That's not good, you know. And when we go around and say, "Oh, you should be locking these, you know, valves off," that's why. So people can't open them. Right. Well, I think Jamie's got a story for you now, so I'll hand over.
Thanks, Simon. So I've got 3 current year claims I'm going to talk about. They're all current, not yet resolved. So the first one relates to this fire hydrant failure in December last year. We can see in the picture there this flange where these 2 metal plates are held together with bolts, and there's a black seal where that interface is. The hydrant infrastructure was serviced quarterly by an external company, but that servicing didn't extend to this seal that isn't really visible. You can only just see the edge of it. So this is what the seal looked like after the event. It's got this rupture that couldn't be seen externally. So this degradation was happening, nobody could see it, and all of a sudden it gave way, leading to substantial release of water, high pressure water, and because it couldn't be seen and detected, there are no third-party recovery prospects in this case because it was not able to be detected externally. So as a result of the release of water, we've got damage across 2 levels of the building, damage to an electrical switchboard, lift pits filled with water, and they're always expensive to deal with, lift repairs. Damage to carpets, cabinetry and general contents, and that's what we can see in this picture here. The flooring's been taken up, the cabinetry's been removed and obviously will be replaced, and the place is just in a mess really. There was scientific equipment present but was largely undamaged, thankfully, otherwise it would have been a much bigger claim. The university, the member suffered no business interruption, which is fortunate because that's not always the case. And the total estimated cost of this claim is about $600,000. So certainly quite a sizable loss from what looks to be a fairly simple failure. All right, and now I'll hand over to Greg.
Okay, so I'll be talking about water ingress through the envelope of the building. Envelope being that part of the building which is protecting the interior from outside elements. So we're talking about obviously roofing, including flashing, facades, glass, glazing and doorways, and sealant between various components. Okay. The components that may be failing, a common one is gutters. A lot of your buildings will be where you may have a pitched roof down to an eave and then to an external downpipe, but not all buildings will be arranged like that. In some cases you may have box gutters, and box gutters, for those unfamiliar with the engineering side, it's a rectangular gutter in from the perimeter of the building. And that would take water you may have a valley where the roof segments are coming down, sloping to this valley gutter going through the middle of the building. It'll go to a transition point, which then goes to the downpipe. They may be various materials. Often, though, I suppose particularly the transition piece is going to be metal. Different types of materials you've got up there. We can get failures often too where it's blocked and then accumulates and then overflows the top of the gutter into the building. Obviously the seals there. So you can have, you have got seals between various elements, whether that can be degraded either with age or for other reasons, maybe inappropriate materials, etc. Roof uplift for the, particularly for the roof, wind uplift for the roof, I should say. With hail damage, obviously and we'll be talking Simon will be talking about the hail testing program, which is largely about impact onto the metal sheeting, causing damage, but nothing to consider is accumulation of hail on the roof, which is then causing blockage. And this, particularly with the later, that can be either small hailstones or large, and particularly with small, they're more likely to form more like a big block of ice, blocking the drainage away. Tree damage, obviously, if you have flying limbs of trees going around, hit impacts with the building, that can cause damage and allow water to subsequently get into the building. With inundation, what we normally think of flood is what you would see where a waterway will overtop its banks and then flood the surrounding areas. We see that on the news for quite a few large events, particularly where I suppose you've got older buildings on campuses. They may have been put in those flood-exposed areas. Hopefully with new ones, they'll be well above that. Having said that, of course, climate change is a bit of an unknown there, so how that's going to affect that. Riverine flood is normally can also be called fluvial. The overland is often called pluvial, and basically that's where you've got intense rainfall, which is the water can't be absorbed by the ground or the drainage system, so accumulates ponds and then flows overland to a lower point. And so that with the latter, it often occurs away from rivers. And the last one they just got there is drainage failure. So of course you've got a lot of in-ground services, but with age maybe there's blockages, even tree roots, etc., that can block that and reduce the capacity of the system to take water away. So of course it's going to back up and accumulate upstream. Okay. Dominant cases, I won't go too much into ageing because I think Simon's pretty much covered that when we're talking about the infrastructure side. I think it's obvious that things will get older and so you're more likely to have failures there. Blockages, and that, as I said before, you could have something like small hail or you accumulating to ice, or leaf litter is a common one, or other debris, reducing the capacity of the drainage system to cope, and then the water then subsequently going in through the envelope. Design issues, what type of box gutters you choose. Architects often prefer to have box gutters because it allows them to not have the gutters or the downpipes on the outside of the building. Sometimes for practicality, where you've got very large areas, you may have box gutters, and also where you've got rooftop plant, might be on a slab, and that may have box gutters there too. Obviously, roof securement, that's, I suppose, once again coming to climate change. If we're expecting more wind, then you may need to think about that. Do you need to have extra lines of securement along there? Or if you're replacing a roofing system with the new system, making sure there's enough securement. Materials, and once again, this will tie in a lot, I think, with the hail testing. If we're seeing more intense hailstorms with larger hailstones, then some materials are going to be more susceptible to damage. Contributing factors, high values, where it's put into a subfloor, and this is obviously largely the universities and research institutes, where you may have instrumentation, maybe trying to get somewhere which is low vibration, but if it's in a subfloor area, it's going to be more likely, if you do have a flood or flow through the building, that it will be damaged. And some cases, collections you may see in subfloors. It's I wouldn't say out of the way area, but it often seems to be that the storerooms will be put down there. Critical electrical infrastructure. Before Unimutual, I was with another insurer, and we're certainly around 2010, or when we had the floods with Brisbane. After that, a lot of the industrial facilities raised their main electrical boards on platforms or in upper levels. And I think with the universities too, there's been quite a bit of work in that area, so that if you do have a flood, that the downtime is going to be less if you're not having to replace the electrical panels. Flow paths, I just mentioned, I said before about overland flow. In many cases, some of your buildings are going to be cut into a slope, but if the topography, or you had development of land where the water is running off, it may be coming down the hill, and even on the uphill side, if you've got high values on that side, it could be exposed. Then deferred refurbishments, obviously, once again, particularly with age, we know that there's some refurbishment required, but maybe budget constraints, whatever, if it's put off, it may mean that you do have a loss as a consequence of that down the road. And finally, I think mentioned before about climate change, obviously that's going to have a big influence in the design for the envelope. It's on there. Leading into that one too, obviously condition assessment, working out where you are with the maintenance and what maintenance needs to be done to maintain the integrity of the envelope is going to be important. And I've had there about approaching storm. Obviously you don't rebuild something with a storm coming, but things like leaf litter or clearing out the drainage or the gutters, making sure that you're maximising the capacity to handle whatever rainfall does come down, can be important. Design, this is particularly, when we talk about hailstorm, we have to consider what's really required there. I think the building code hasn't really considered hail much in the past, but yes, obviously, particularly with important research areas, you don't want to have damage allowing water egress to come through there. With the measures of reduced consequence, I think location is quite important. The other three there really are not specific to the envelope, but more, you'd say, for infrastructure, but I've just listed them there. And finally, I think most of these issues anyway we've already covered off anyway, but some issues to consider there anyway. And with that, I shall hand back to Jamie.
Thanks, Greg. So this is an example of a box gutter claim that we've got at the moment. That's the underside of the box gutter seen from inside the building. This is a concrete box gutter that's 110 metres long, so it's very long and it's a big building, and as I understand it, the whole roof area of the building drains to this box gutter. The outlets originally from the box gutter were about 50 millimetres up the side of the gutter, which is a bit hard to understand. So as I understand it, this 110 metre length would usually have some water in it, and then when it rained and reached the 50 mil level, it would go down some downpipes. The building originally was a tiled roof, and the box gutter had a copper lining, and so that all worked fine. At some point, the tiled roof was replaced with a metal roof, and there were corrosion issues between the steel roof material and the copper lining of the box gutter, leading to leakage issues. So the member decided it needed to upgrade this box gutter, and it was going to switch to a siphonic drainage system, which is a lot more efficient for draining a large roof area. This work involved drilling 48 penetrations in the base, in the bottom of the box gutter. And during this work, the original downpipes were removed and the holes for the water were sealed. So there was a period of time where this roof effectively had no drainage. On the 12th of December last year, the contractor was alerted to the fact that light rain was expected over the weekend. And the member and the contractor had calculated that this gutter could hold 18,000 litres of water in the event of light rain, and they felt that that would be fine. But on the Sunday there was a severe thunderstorm involving 40 millimetres of rain and about 125,000 litres of water falling on this roof with nowhere to go. So the box gutter filled up and then emptied into the building, leading to significant flooding across 4 levels. The total incurred value of that claim currently is $575,000, and a recovery against the contractor is being explored. You can see that this is really an unacceptable situation to leave a building with no effective roof drainage for any period of time. So the final claim I'm going to talk about is a mould claim. Mould is excluded under the property protection, but it is covered if it arises from a protected peril. So in this case, the member had a piece of equipment called an air handling unit, which looks something like this. It's part of the air conditioning infrastructure, and it failed over the Christmas New Year period. And we often see certain types of claim over the Christmas New Year period because there aren't any people around to detect that something's gone wrong. So this piece of equipment failed. The humidity rose because there was no air conditioning for probably 10 days or so, and this led to significant mould growth just because it was a warm and humid time of year. So it resulted in mould on furniture, flooring, ceiling tiles, walls, doors, all that sort of thing. The cost to fix this is apparently quite low at $60,000. I was expecting it to be much higher. I've explained that mould isn't covered under the property protection except if it arises from a protected peril. Sometimes there is mould that arises for atmospheric reasons or because of the way that the building has been built. That isn't covered. We do have a claim for mould of that type under the environmental protection at the moment, and we're waiting to see how that plays out. But there may be some cover there for that situation. And with that, I'll hand over to Glenn.
I'm going to try and speed it up a little bit, not because I've forgot my glasses and can't read my own writing, but more so we've got some time for questions. So Jamie's just shared a few different examples, I guess, of how relatively contained issues or incidents can escalate pretty quickly. And from a risk and protections perspective, our critical takeaway is that prevention is always, almost always cheaper than remediation. And like Simon said, you know, if you're spending money remediating things, then that's a dollar that you're not being able to do something new with. And that's the reason for the cost difference, obviously, is because remediation costs aren't just about fixing the asset. They also include the business disruption, displaced staff and services, secondary damage, and then extended claim duration. There's a couple of speakers that we've got tomorrow that are talking about both prevention and remediation and practical examples on how they're run through their organisations. And I think they're really good examples of I guess, how to mitigate against this and protect your institutions. Whilst we look at buildings and the built environment a lot on our surveys, when we're out with the members, we do look to consider the elements of the environment and climate change and the impacts that each of these have on our built environments as well. And so I'm going to try and look at it from a risk and loss lens rather than a facilities one at the moment. But if you've got any questions, if this sparked anything, come and see us. Otherwise, we'll be interested in your experiences as well in your organisations. Most institutions are pretty good when it comes to the flood and bushfire planning, and maybe that's because they're the big ones that you see on the news, and they're the really dramatic ones. We also see good testing and good practice alongside evacuation procedures and planning as well. But from a risk perspective, whilst they might be the most obvious perils, they're not necessarily the most loss-intensive ones over time. Heat, for example, is something that drives system stresses, power demand issues across broader networks, and we see the failure of plant and ultimately business interruption. And these can impact things like not just your buildings and your assets, but the loss of critical research, medical, health facilities, all that sort of stuff as well. Now, the point here isn't that flood and bushfires are not important, because they certainly are, but they're not really the whole picture of the things that we need to face. And they'll all contribute to loss, often in combination, and it's the outliers that tend to catch institutions off guard. As Simon touched on earlier, we've got Cyclone Narelle, which is in the news at the moment, and other convective storms are often happening, and it's interesting to sort of stop or pause and think about how violence at a local scale drives significant damage. We often experience tornadoes as well, although we might not hear it much, and they might be smaller than what's seen in the US. They're equally destructive to buildings and whatever's in its path. And these types of storms share the same characteristics of being localised and causing highly severe damage. And they often bring hail, like Greg was talking about, the wind uplift or the pressure differentials in buildings that cause roof failures or other envelope failures. And what our claims history is telling us is that they're becoming consistent with a higher frequency and then a higher loss as well. Drought's a little different in that it operates over a longer term and it amplifies exposures through reduced water availability and increases the heat stresses in your environments and elevated fire risks as well. The common thread across each of these ones is that the loss is increasingly coming from perils that are difficult easy to underestimate. So I guess the question is next time you're doing a bushfire plan or a flood mitigation plan or a EVACs, have a think about some of these other things that might hit you as well, and ask the questions around what are you doing and how do your environments, how are your environments resilient to these sorts of climatic impacts. I guess here the slide's highlighting where risk often compounds. The infrastructure stress, power outages, access constraints, ageing assets, they're not occurring in isolation. And it goes back to that question that's important for the room, I guess, is how are your institutions engaging broadly enough, that's cross-unit, cross-institutional, with all of your members, to understand the business impact and continuity risks across your entire asset portfolio. And I'm not talking about a single site or a campus as a whole. I'm talking about every facility, every operation across that's supporting your critical operations and your revenue generating drivers. And without sort of a comprehensive overview of the business impact assessments, it's going to be really difficult for you to understand what your true exposure might look like, how to establish your continuity processes, or build meaningful prioritisation or some redundancies in those as well. Finally, I think resilience isn't just a single action, it's a portfolio of decisions made over time and ongoing. And from our perspective, the key focus for us is that institutional prioritisation and having that opportunity to invest where the risk to your continuity and loss is the greatest. And when it's done well, they'll reduce your claim volatility and the duration of your disruption. Hail is one of these hazards that sort of sits within this strategic space. So I'll bring Simon back to talk about a project that we've started on now to directly address one of these issues.
What do we know about hail? Someone tell me something about hail. It's hard. Is it getting bigger? It's getting bigger, trust me. See these little hailstones here? How much energy do you think's in one of them falling at terminal velocity? 1 joule of energy. For every centimetre it increases in size, it exponentially increases in energy. We thought it was important, given that when we did a data analysis of the losses, that we started to see an increasing cluster of not insignificant claims in the last 10 years. And we were thinking, well, climate change, what's this going to be like in the future, right? How's it going to look for us? I mean, hail's just one thing, right? But it's an important thing because it's costing Unimutual money, it's costing the insurance industry generally money, and it's costing us all excess, right? So what we've done is we've partnered and collaborated with TEFMA, the Tertiary Education Facility Managers Association, and engaged the cyclone testing station at JCU to undertake some hail threshold damage assessments. So effectively what that means is shooting some hail at different pieces of equipment and finding the point where it breaks. And we got some video for you of this on Friday. It's a cracker, literally. It's okay, you don't have to laugh, that wasn't a joke. All right. The important thing about this threshold testing is it's going to tell us a couple of things. It's going to improve awareness, obviously, but it's going to give us some empirical data that we can base modelling on, right? So we'll be able to do our loss estimate calculations for hail on a campus using the COPE information that you give us, right? We've already developed that model, but what we really need is that empirical data that says when hail gets this big, this much damage happens to different types of material. And what that'll do is ultimately inform more appropriate material selection and protection strategies moving forward, right? And I'll tell you why that's important in a minute. And ultimately, this project will result in the basis of an open source research paper. So it'll be available to everyone. Unimutual and TEFMA will get the results first, which we'll be able to share with our members, but ultimately it'll be available to the broader community. So that's a really exciting project that we've already embarked upon and which you'll hear more about on Friday, assuming Dr. David Henderson is able to get down from Townsville after all these cyclones that have been going on. And I've got a phone call with him in 20 minutes, so I can update you later on that. Now this is that hail testing is one piece of a bigger picture, and that is the development of resilience guidance material by Unimutual. And why is this important? Well, climate change is real, it's not going away. We need to understand how that's going to impact us, not necessarily now, but in 50 years, right? When our kids and our kids' kids are going to university. We've got I think we've got an important legacy, intergenerational legacy to leave for these kids, right? So what we build now, we need to be resilient in 50 years' time, right? So think about the planning now. It's not somebody else's problem. Let's make it our problem to fix. We've been part of the problem in the past. Let's be part of the solution for the future. And how do we do that? Well, the guidance material covers things like understanding what natural perils are going to affect your particular location, right? And how you should deal with that in the future. What does it look like, right? What's its shape? What are the adaptation and sustainability strategies we can employ now and also into the future? But more importantly, you know, our design standards for buildings and infrastructure need to reflect now what we need to do in the future. And look, you know, a lot of people will come back to you when you make this suggestion and go, well, hang on a second, the NCC says we don't have to do that. That's the National Construction Code. It's focused on life safety. It's not focused on asset resilience, right? So just bear that in mind. There are more things than life safety. You know, we want to leave legacy assets for our kids into the future. We just don't concentrate on buildings, you know, energy, infrastructure, water security across campuses. They're all a part of the resilience picture, right? So how do we deliver that? You know, so you tie up your design standards, you know, you roll that into your campus master planning, and that's how we create resilience, right? So we bring all of these pieces together, you know, the hail testing data, all the other data we have on the various natural perils, you know, our understanding of how, you know, we've failed in the recent past with some of the events that we've seen, and how do we build that into resilience in the future. So that's pretty much, you know, here ended the sermon, by the way, you know, but I think it's an important, you know, it's an important point to make. We've got an opportunity to leave a legacy, so let's do that. And now I'll open it in the last minute for questions. If there's no questions, if you don't want to ask a question, come and see us later if you want to discuss this issue, because it's an important issue. So thanks very much, everyone. I hope we left you with something to think about. And a couple of the items that we talked about, so mould and hail testing, there'll be 2 sessions during the course of the next 2 days focused on those particular issues. So once again, thanks very much. And it's afternoon tea, but I've got one last important message, and it's from Christine, and I'm not going to disobey Christine, and that is that you should take everything you have with you when you leave the room, because the rooms are going to be reconfigured. Okay? So thanks, everyone.